Welcome back. In this video, we'll discuss the double eccentric rotary plug valve design. To start, we need to talk about what the double offset terminology actually means. And simply what it means is that there are two offsets within the valve. The first offset is from the plug face to the valve center line, and the second offset is from the plug face to the shaft center line. What that means in simple terms is that the trim is not located directly in the center of the valve, it's slightly offset to one side of the valve. So when you progress from fully open to fully closed, the valve trim will actually now cam into the seat. And by doing that with the C-shaped plug design that it has, there is going to be no friction along the way, which will therefore reduce the wear and tear on the trim itself. In addition to reducing the wear and tear, because there is no friction, you also reduce the amount of torque required for the actuator. So now you have the ability to go with smaller actuator sizes, so there is the cost benefit there. It also allows for more accurate control than other rotary plug valve or rotary control valve types. There is no dead space within the design itself, so you eliminate any potential spaces for particles to build up if you are dealing with an application with a dirty medium. And lastly, similar to a globe valve, you have multiple CV options per size. With the SAMSON VTEC rotary plug valve specifically, you have 4 CV options per valve size, which now allows you to adequately size and select the ideal CV to optimize flow control within the valve itself. Some of the features continued, less flow disturbance. What that essentially means is because the valve is a trunnion mounted valve, you have an upper shaft and a lower shaft or trunnion bearing. So the shaft does not go all the way through the valve itself. So what happens is when the valve is in its fully open position, you have a free flow path, which is going to reduce any turbulence going through the valve, which if there was turbulence would contribute to extended noise levels, as well as create wear and tear potentially on the trim as well as on the guiding part. So again, with the VTEC design, you avoid the turbulence, so you avoid any of the negative effects that would come with it. In addition, because of the free flow path, you're also able to maximize flow capacity and extend the rangeability of the valve technology itself. So if you remember from the first video, I talked about the globe valve having a rangeability of 50:1 up to 2-inch size and 30:1 above 2-inch size. And then the segmented ball valve having a rangeability of greater than 400:1, so you can see how this solution would now fit within the middle. Various actuator options. Because of the low torque requirement due to the valve design, you can now use various actuator models depending on what the customer requirements are, so rack and pinion, spring diaphragm, as well as piston or Scotch yoke style. And lastly, longer service life. Again, because there is no friction with the valve trim in operation, you're able to extend the service life of the valve itself. And to summarize, the advantages and disadvantages of the rotary plug valve technology. Again, high rangeability up to 200:1. We talked about why that might be beneficial. Suitable for precise control, so you still get that high level of control from a rotary control valve. You're able to use it in high differential pressure applications. So again, although a globe valve is ideal for very high differential pressures, this is a good secondary solution where other rotary technologies would not be adequate. You have the straight flow path, which will maximize rangeability. No dead spaces, so you won't get buildup of any particles, and that makes you very versatile to use it both in clean mediums as well as dirty mediums. Suitable for high switching applications if ever you needed a valve that needed to open faster or close faster. This would not wear out fast in being able to do that. You reduce the actuator sizes due to the low torque requirement from the valve, and it's an overall compact design. On the disadvantages, it has limited noise attenuation options compared to a globe valve. That's not so much a disadvantage because, again, a globe valve has all of the different solutions available to it. This still has many solutions available to it, just not as many as a globe valve would have. And lastly, it has an inherent characteristic, which is almost like equal percentage and linear characteristic combined, which again is not too big of a disadvantage because your positioner is going to be your final control element in where you would be able to select a setting to control it as equal percentage or as linear flow. Thank you. Stay tuned for the next video where we'll go through valve selection criteria.